ladies and gentlemen, let's take a further look here into quantum computing. Is there an app for that? That's the question, a nonsensical question. After all, what kind of app would that be, and what kind of systems would it run on? And, well, why would we need any such thing? Well, eager to hear the answers, and those come from Josef Reger, and he is Fujitsu Fellow and Chief Technology Officer in EMEA at Fujitsu, which means in his role he covers about a third of the globe, I would say. Well, welcome, Josef. Great to have you here today.
Well, thank you. Hello, everyone, and please brace yourself. To stimulate the discussion, I'm going to take a different view, even if everything seems to be just fine. Do you recall? The artificial intelligence story started some 60 years ago. And do you recall what happened in the first 55 years of those 60? Nothing much? Not quite. There were a number of so-called AI springs, meaning spring like winter, just spring, meaning like excitement, a lot of funding, a lot of interest in artificial intelligence. Sadly, the AI springs were all followed by AI winters, depression, no funding, no interest. Why was that? Well, perhaps because the research was just too academic and the industrial applications were not coming. So it seems to be all about applications and perhaps apps. Fully developed quantum computing might be a decade away, or maybe two. If we don't want a bunch of quantum winters until then, we need to be mindful about quantum applications and the apps. So that's the title of this brief talk today, and I have 10 more minutes. That's the title, Quantum Computing, is there an app for that? And of course, I'm referring to the iconic Apple marketing campaign, there is an app for that, after the launch of the iPhone. Soon there were apps for most everything, making the apps more important than the hardware. Apps more important than hardware. Keep that thought, hold that thought for a minute. Let's go back to quantum computing and ask the question again, is there an app for that? Again, nonsensical question, is it? Or is it? What do you mean, or what do I mean by an app anyway? Well, at this point, it could be three things. One, do I mean quantum computing as an app running on a classical computer, like on a simulator? Those simulators, quantum simulators, which simulate a small quantum computer on a classical machine, do exist, like Ethos quantum learning machine. So there is an app for that. Not useful commercially, and it never will be. And there is no hope. It's physics. But such an app is still important because one can learn quantum computing, develop skills starting right away. Or two, do I mean the real thing? Do I mean a quantum app running on a quantum computer? Well, in a select few cases, perhaps 100 or so, there's an app for that, but not more. Sadly, commercial benefits are limited today because there are only a few, and they deal mostly with math and physics problems. They're important too, but we don't have enough algorithms. Look at, say, quantumalgorithmzoo.org, and you will see. Yeah, this will change. Someday, there will be lots of apps. We better hurry up developing those, and that could be a competitive advantage. These apps, I would argue, are more important than building dozens of different kinds of small toy, as it were, quantum computers. Or three, do I mean something else? Do I mean something like a quantum technique on a special but classical computer? It must be special, that's clear. We just saw that with the simulators. Traditional ones will not be sufficient, but we can have a simulator of kind, or even better, an emulator. The difference being quantum emulators don't do exactly what quantum systems do. They just do something like it. Or we could have a special kind of quantum computing. We could have an adiabatic quantum computer, and there are many apps for that already, for adiabatic quantum computing. Now, the beauty of the adiabatic emulators is that these apps run on that special system as well, without the hardware being in a quantum state. And there are commercial benefits available today already. It turns out one can get far, very far, by using non-quantum hardware. This is remarkable. So what we need to do now depends on what we are after. The purest approach, universal quantum computing for its own sake, is one possibility. But then we are in it for the long haul. Time frames and commercial benefits are uncertain, and quantum winters are almost certain to come, independent of the amount of money we pour onto it. This needs to be looked at and researched. The pure quantum computers, the universal ones, need to be looked at, need to be researched, but with what priority is the question. Or instead of being purists, are we after applications of quantum technologies? Again, this is possible today in many commercially relevant areas, many industries. We can use adiabatic quantum computing, like D-Wave builds them, or we can use the so-called bridge technologies, or sometimes called quantum-inspired technologies, which is essentially a quantum or quantum-inspired software running on a special but classical hardware. These are not simulators, as I said. These are emulators. They don't work exactly as quantum computers. They just mimic how the adiabatic quantum computers work. But they mimic it with the performance that makes them interesting for today's industrial problems already. They do a remarkable job on combinatorial optimization problems. And those are very common in industrial optimization of any kind, in any industry. And we don't need to be looking for them. They are there. Non-quantum hardware, but still quantum-like performance. So I argue that we should not be totally fixated on quantum hardware. That's largely a material science issue anyway. There are different kinds, and we heard them in this morning. There are superconducting based, actually most of them are superconducting based. That's the low-hanging fruit, the most obvious route to quantum computing. But I doubt that we need a dozen different kind, small superconducting quantum computing projects. There are semiconductor-based, like using trapped ions. These are more promising, perhaps. There are exotic materials that come in using diamond and graphene, photonics-based, which are very interesting to me. I think they have legs to go. And it might change over time which one of these is the more successful one. Remember, materials science is not quantum computing. Materials science is perhaps part of quantum computing. So there is the question of quantum software too, the algorithms and the applications. We do need hardware, we need quantum hardware, but we concentrate too much on hardware today. Look at the available funding, and I heard the words this morning. I heard the words, but I also look at the money, and most of the money is spent on hardware. But that hardware is toy hardware, commercially not very relevant today. So this is what I have to say. Quantum computing might not be currently as big a deal as electronic computing was 70 years ago, but it will be a very big deal someday, unless replaced pre-birth by something equally or even more complex, which will pose the same challenges to us as quantum computing does today. So we better learn it now. We need to get better in how we develop and introduce complex technologies, how we integrate them with existing hardware, existing system landscapes. How do we develop not just the hardware, but the software too? And how do we develop the required skills? And crucially, this is to me very crucial, how do we put the technology to good commercial use as soon as possible via the creation of instant ecosystems? So why don't we do it a bit differently, cooperate closer, create a better ecosystem today to develop a software abstraction layer that uses available hardware, small universal quantum machines, the few qubits that we can do today, the much better adiabatic quantum computers that are available today, the emulators that do a wonderful job in optimization, and even simulators to learn it and develop skills. Again, running on available hardware to develop algorithms, skills, curricula, platforms, communities, value chains, all to develop quantum computing apps. This is possible today because there are many commercial quantum opportunities already, not in the future, already. For many, we could say then, if we do this right, there is an app for that. Thank you.
Well, thank you very much, Josef Reger. Very inspiring, very passionate speech, and indeed a lot to think about and to discuss further. And you are also going to be in the Meet the Speaker session here today. So whoever wants to get in, well, deeper touch with you may do so. I have one concluding question for you, actually. As you said, you also talked about use cases, and the previous speaker did. From your perspective, seeing so many regions of the world, what would be use cases that between regions where they collaborate well, like best practices, maybe a public-private partnership that you would say where we can learn something from in Europe?
Well, the regions are not all that different. Almost everybody struggles with the question whether this is a purely academic research discipline, or we can put it to good use, as I said, immediately, and targeting industrial optimization problems. And frankly, the best region, because the problems are here, is in Europe. With our industries, our manufacturing industries, pharmaceutical industries, even the banking industry, and so on. So I don't like this, we are leading and nothing can be better than it is today. I don't like that attitude, and we are not leading, by the way. But we have the best chance here in Europe because we have the industries who need these technologies today. The problems are there. We don't need to be looking for them. We can easily find them and do a remarkable industrial optimization job. Now, that's not all what quantum computing can do. It will be able to do more than that, but that's an awful lot to start with.
Well, thank you very much, Josef Reger, at this point. And great listening to you. And well, thank you for your time, and have a good discussion in the Speaker's Corner. Thank you.